And welcome to the fourth chapter of Waveform Generators of the subject Applied Electronics. Myself Sanjit Kumar Singh, lecturer in Electronics and Telecommunication Department at Praveen Patil College of Diploma Engineering and Technology. So this chapter is of 14 marks and of 12 hours. After going through this presentation and the subsequent presentation on this chapter, the learner will be able to know and calculate the frequency of oscillation for the given type of oscillator circuit. Select the relevant oscillator to obtain the given range of the frequency with justification. Choose the relevant sweep generator to obtain the specified sawtooth waveform with justification. And fourth, prepare a specification of the given oscillator. The course outcome of this unit or chapter is to use BJT as waveform generator. So the topics to learn in this presentation and the second presentation are: the first one, oscillator, introduction to the oscillator, the need of oscillator, oscillator and amplifier comparison, then condition for the oscillation, that is Partition criteria, classification of oscillators, number 3 4.3 sine wave oscillator, and in that we will be studying about RC phase shift in this presentation, and the remaining crystal oscillator concept of working and application will be studied in the next presentation. And the fourth point or topic, sweep generator, will be also studied in the next presentation. So the oscillator, what basically is an oscillator? An oscillator is a circuit which produces a continuous repeated alternating waveform without any input. Very important, without any input means we are not providing any external signal like the amplifier, in which we are giving a signal and the signal is amplified. Here in oscillators, the oscillators are basically circuit or device that is converting unidirectional current flow from a DC source into an alternating waveform which is of the desired frequency as decided by its circuit components. What is the need of oscillator? As oscillator is used to generate particular frequency of a signal, and RC oscillator generates low frequency signal. If we are making use of LC oscillator, then it will generate high frequency signal. An op-amp based oscillator will operate in the stable frequency range. So oscillator's frequency can be varied by varying the component value with potentiometer arrangements, CRO signal stabilization, and signal generators in typical college laboratory are simple oscillators. Oscillators used for tuning circuits in audio systems, video systems, radio, TV and other communication systems. All these applications state the need of oscillators. So the principle behind working of oscillator is the sustained oscillation. The oscillators are nothing but the amplifier circuits which are provided with a positive or regenerative feedback, wherein a part of the output signal is fed back to the input, as we can see in the given typical oscillator block diagram. In order to obtain the oscillations which are continuous and of constant amplitude, one needs to compensate for the energy loss. For example, if we have a tank circuit, we know the capacitor will be discharging through the inductor, and as the current flows through the inductor, the polarity of the current will be upper end as positive and lower end as negative. And as the discharging current decreases, the inductor stores energy in uh, its field, magnetic field, and that will be reversing its polarity once the discharging current approaches or nears to equal to 0. So at that moment, as the polarity is reversed, the lower end becomes positive and the upper one will become negative of the inductor L, so that it makes the current continue in the tank circuit, LC tank circuit, as inductor has the property of changing any or opposing any change of current. So now the inductor will discharge its energy through the capacitor. In another way, it is charging the capacitor with the reverse polarity, the lower end positive, lower plate positive and upper plate negative. So in this way, charging and discharging of capacitor takes place, and that makes a sine wave generated, as we see on the right hand side waveforms. Now this sine wave will decay slowly unless we are providing for the losses that is taking place in the charging and discharging of the components L and C of the tank circuit. So this external power has to be supplied to compensate for the energy loss, otherwise it will decay after it has dissipated the energy. So on the right hand side we see the typical block diagram of the oscillator. So oscillator, what we see is consisting of an amplifier with the feedback but without any input. So there is no input given, sine wave given to be amplified, but the noise generated within the amplifier circuit or the feedback circuit is amplified and is converted to sine wave or triangular wave as per requirement. So a part of the output is fed back to the amplifier input. The three cases of oscillations produced, we see when this energy provided externally is more than the energy that is lost, then we see the increasing oscillation. Then if the energy provided is less than that of the energy dissipated, then there is decrease in the amplitude with respect to time. And if we are providing enough energy to compensate for the loss in the tank circuit, then it is slightly greater than the losses taking place inside. So it will have a sustained oscillation. The C waveform, we see constant amplitude oscillation. So in order to compare the amplifier and oscillator on a number of parameters, first we see the amplifier. What is an amplifier? So amplifier is an electronic circuit which gives an amplified output of the input that is fed to it, whereas an oscillator is an electronic circuit which gives output without application of input. So there is no sine wave input given to the oscillator circuit. The amplifier does not generate any periodic signal, whereas oscillator will generate periodic electronic signal. Amplifier uses negative feedback, whereas oscillator is using positive feedback. Amplifier operates as a multiplier, whereas oscillator is as a source. Amplifier provides amplified signal, whereas oscillator is giving oscillatory signal. Amplifiers do nothing until input signal is fed to the input. Oscillators produce signals from the moment of power, means when it is powered it will start working. So these are the major comparison points. One more point with respect to the block diagram representation, we can see amplifier can be represented as input signal with the output signal, and to amplify the input sine wave signal we require DC power or DC energy supplied from the DC source, whereas an oscillator does not require any external AC signal, but the DC power provided is sufficient, and the amplifier and the feedback circuit or the phase shifting circuit is sufficient to produce the noise signal, and from the noise signal amplified version comes out as per required. Now the conditions for the oscillator, conditions which are required to be satisfied to operate the circuit as an oscillator are called Partition criteria for the sustained oscillations. So Partition criteria are very important to be maintained in order to have the sustained oscillation. So what are those criteria? And unless and until these criteria are fulfilled with a positive feedback to ensure the sustained oscillation, we will not have a sustained oscillation unless and until one or both, either of the two criteria or both the criteria are not fulfilled. For an oscillation circuit, there is no input signal as we see in the block diagram of oscillator. Vs, no Vs given, hence the feedback signal, Vf signal itself should be sufficient to maintain the oscillation. The Partition criteria as stated, the loop gain, that is the loop gain, the gain that is provided by the amplifier and that of the feedback, the product of the two has to be equal to 1, and the second criteria is the phase shift around the loop is 0 or an integer multiple of 2 pi, that is 360 degree. So that means the angle between beta, the feedback factor, and amplifier gain A should be equal to twice pi n, where n could be equal to 0, 1, 2 or so on. The product beta A is called the loop gain because it involves amplifier A as well as beta, the feedback factor of feedback network or phase shifting network. Now it is necessary to maintain the amplitude of sustained oscillation. In practically, oscillator loop gain is slightly greater than 1 in order to have a sustained constant amplitude output. Now what are the types of the oscillators? There are different ways of classification. One way is based on the output waveform the oscillator produces. So sinusoidal oscillator, if sine wave is produced, non-sinusoidal oscillator, if non-sinusoidal signals like a square, rectangular or sawtooth waveforms are generated, then these are non-sinusoidal or relaxation oscillators. Such oscillators can provide output at frequencies ranging from 0 to 20 megahertz. The non-sinusoidal can be 20 megahertz signal. So now based on the circuit of components, the components that are used in the oscillator circuit, then based on that we can have RC oscillators if resistor and capacitors are used, LC oscillators, inductor and capacitance are used, then crystal oscillator if crystals are used, and we also have the negative resistance oscillators, that is making use of the negative resistance region or characteristic of such as that of the tunnel diode. Uh, Tunnel diode oscillator is an example of negative resistance oscillator. Now, based on the range of operating frequency, we can also classify the oscillators. The first one is the low frequency oscillator that could produce output of 20 hertz to 100 or 200 kilohertz also, and is also called audio frequency oscillators that covers the 20 to 20 kilohertz range as well. High frequency oscillator which is producing 200 kilohertz to 300 or to gigahertz range frequency, and are also called ratio frequency oscillators. Based on whether the feedback is used or not, we have the feedback oscillator, non-feedback oscillator, and in this oscillator use the negative resistance that on the characteristics of the device, like UJT relaxation oscillator. So in this way we can classify the oscillators. Sine wave oscillators. The sine wave oscillator nature of a sinusoidal oscillations. The nature of oscillations in a sinusoidal wave are generally of two types. They are damped and underdamped. Undamped oscillations. Damped oscillations, where the electrical oscillation whose amplitude goes on decreasing, as we see on the right hand side, the amplitude goes on decreasing with time, are called damped oscillation. The frequency of the damped oscillation may remain constant depending upon the circuit parameters. Damped oscillations are generally produced by the oscillatory circuits that produce power losses and does not compensate if required. Undamped oscillations. The electrical oscillations whose amplitude remains constant with time are called undamped oscillations. The diagram on the right hand side shows the undamped oscillation. The frequency of the undamped oscillations remain constant. Undamped oscillations are generally produced by the oscillatory circuits that produce no power losses and follow compensation techniques if any power losses occur or take place. Next topic is principle of phase shift oscillators. So we know the output voltage of an RC circuit for a sine wave input leads input voltage. The phase angle by which it leads is determined by the value of RC components used. If R were reduced to 0, if resistance is reduced to 0 or short circuited with the help of a potentiometer, then V1, the voltage across V1 dash, will lead the V1 by 90 degree. That is, phase difference is 90 degree between the voltage, input voltage V1 and V-1. In practice, the resistance is varied to such a value that makes V1 dash to lead V1. The output across resistor will lead V1 by 60 degree. So that is the principle behind the phase shift oscillators. RC phase shift oscillator for a single stage consisting of resistor and capacitor. Similarly, if we are making use of such 3 stages, then we can have 360s, that is 60 degree, 60 degree and 60 degree, total 180 degree of phase shift provided. That means if input is positive and negative half cycle, output V-1 will be negative and positive half cycle, that is 180 degree phase shifted. So if this RC feedback network or phase shifting network is used as a feedback circuit, a path for the C amplifier, then the circuit we see down here is that of the RC phase shift oscillator circuit, where we have the C amplifier with the resistor RB, RC, the transistor RE, and the bypass capacitor CE. And the feedback path output of the amplifier is taken from the collector with the help of the coupling capacitor CC, and this output or a part of this output is fed back to the input of the base of the transistor through capacitor C1, R1, C2, R2, C3, R3. So these three stages of RC network forms the feedback circuit or phase shifting circuit. So here the amplifier, since it is C amplifier, provides 180 degree phase shift, and the another 180 degree phase shift is provided by the RC phase shift network. So total phase shift in the amplifier and in the feedback circuit is 360 degree. So we get 360 degree phase shifted for the closed loop. Now this 360 degree phase shift or 180 degree phase shift for the three stages of RC network will take place at only one frequency, that is the frequency of oscillation, and this frequency of oscillation is given by f0 is equal to 1 upon 2 pi RC into root 6. This is the frequency of oscillation for RC phase shift oscillator. So at this frequency, the beta required for the feedback factor required is minus 1 by 29. Hence AV should be at least 29. The gain or open loop gain of the amplifier should be 29, so that the product beta times amplifier gain, that is the feedback gain, is greater than 1. So for that the three stages of the RC feedback network will have the three equal values of resistors and three equal values of capacitors, R1 equal to R2 equal to R3 is equal to R, and the three capacitors C1 equal to C2 equal to C3 equal to C value. Now how it operates, the circuit when switched on, or it starts oscillation at the resonant frequency f0. The output E0 of the amplifier is fed back to the RC feedback network. This network provides 180 degree of phase shift, and a voltage EI appears at its input, at its output. So here we see the output of the RC phase shift network, that is the input for the C amplifier EI, and E0 is the output signal that is fed to the RC network. So the feedback applied will be M is equal to, here for example, EI by E0. The feedback is in correct phase, whereas the transistor amplifier, which is in C configuration, produces a 180 degree phase shift. The phase shift produced by network and the transistor aid to form a phase shift around the entire loop. Entire loop is equal to 360 degree. Now what are the advantages of RC phase shift network or RC phase shift oscillator? So It does not require transformers or inductors. That is the major advantage. Secondly, it can be used to produce very low frequencies. And thirdly, the circuit provides good frequency stability. Now, the frequency stability of an oscillator can be dependent upon number of factors, or the change in oscillation frequency may arise due to the following factors. It may depend upon the operating point of the active device, secondly upon the circuit components, and thirdly it could be on output load, fourth it could be on supply voltage, and the frequency stability of an oscillator is also it is also dependent upon inter-element capacitances and stray capacitances. So the disadvantage is starting the oscillations in difficult. It is difficult for starting the oscillations as the feedback is small, since we are not providing any external sine wave signal for amplification, but the feedback circuit itself is generating the noise or a small signal, and that is amplified. The output produced is small. So these are the two major drawbacks of RC phase shift network. So this RC phase shift network can be used for transistor BJT based circuit, or it can be used for FET based circuit, or even op-amp circuit, op-amp amplifier based also can be implemented. Applications: the FET phase shift oscillator is used for generating signals over a wide frequency range, that is 100 few hertz to 200 hertz, or it could be designed for 200 hertz to 2 kilohertz, or 2 kilohertz to 20 kilohertz, and 20 kilohertz to 200 kilohertz can also be obtained using RC phase shift network or oscillator. So this type of oscillators are used in musical instruments, for then for voice synthesis, and in GPS units, since they work at all audio frequencies. The entire 20 to 20 kilohertz range of the audio frequency is covered. So thank you for this presentation, patiently listening to it, and the references one can refer to down here, it is given. Thank you very much.